In this video, I'm going to show you how to calculate the percentile using a frequency table. To do this, we're going to use something called interpolation, which is going to help us estimate the percentile that we're looking for. So similar to the questions that you have in your homework in Applia, here you see a set of numbers that we want to find the percentile. So the percentile that we're going to look for here, we're going to look for the 80th percentile. Okay, so the first thing that we're going to do is to put our numbers, our sample numbers, into a frequency table and calculate the cumulative frequency percentage. So I've started the table here, and we're going to put the first set of numbers in. And what you want to do with this is make sure that the highest numbers in your data set appear first. So we're just going to enter these going down the row. And you can follow along and do this with me. All right, let's make sure that we have all the numbers here. Okay. All right, now for this scenario, there's just going to be one in the cumulative frequency column. There's only one observation for each of these. So this should be relatively easy to construct. It is just going to be the numbers in our data, the number of numbers in our data set. So these are probably going to be slightly a little off. In lining up. So where this number came from, we have this bottom number here. There's one of those. This number plus this number, we now have two numbers. Here we have three numbers, four numbers, and there's nine numbers in our data set total. Now over here in the cumulative percentage, we are going to just do the cumulative percent of the total sample size, which is 9. So to calculate the very first number, you're just going to take 1 divided by 9. And we're going to enter these in here. So see if I can get these to line up. So you're always going to have 100% at the top. Okay. And these numbers that you see here, so all I did was take 1 divided by 9 and got this percent. Okay, but we are looking for the 80th percentile. So we know that the 80th percentile falls somewhere in between here. So this is the 77.8% and the 88.9%. We don't have 80% that shows up here, so we need to estimate that. So to use interpolation, we are going to set up this little table, which I highly recommend that you always do. So we are looking for the number that corresponds with the upper and the lower limits that we see here. So we know that 29.1 is there, and the percentage associated with that is this 88.9%. We don't know what the value is. That's really what we're trying to find. But we do know that we are looking for the 80th percentile. So I'm going to put this number here. Oops. And then we do know the bottom number, which is the 24. $28.9. And that's 77.8%. Okay, so the next step that we're going to do, and let me see if I can't switch over here. This may not work that great. We need to find the distance from here to here. So to do this, all we're going to do is subtract 88.9, or subtract 77.8 from 88.9. My pencil isn't working, so it's 88.9 minus 77.8. So hopefully you're doing this on your calculator, or you're doing it by hand, and you're getting this number faster than I can write this for you. Okay, so the distance that is between these two values, you should find that it is 11.1. Okay, so that's the first value that you need. Then the second is the distance between this bottom number, the 77.8%, and the percentile that you're looking for. So 80 minus 77.8 is 2.2. Now that you have that number, what we're going to do is we are going to use these numbers to develop a ratio of these differences in distances. So we're going to take the bottom difference there, the 2.2, and we are going to divide into that the distance between the very top number and the bottom number. So we want to find this number right here, which you should get 0.1982. Okay, and we're going to use that to plug into an equation here in a minute. Now, the other thing that you need to do is you need to consider the upper limits, so the real limits of the values that we're looking for. So again, we are looking for different color here, right along these values here, okay? So the upper limit for this 28.9, let's see if this might work better for me, is going to be 28. Well, it's not going to work for me. This is the upper limit of the lower number. So here it is 28.05. We simply took that 28.95, sorry. We took this number here and just found the upper limit of that one. We also need to know the upper limit of the highest number. So that here is the 29.9 0.1, so the upper real limit of that is 29.15. And now that we have that, combined with our other numbers, we can calculate the percentile. So we're going to take the upper limit of the lower number, which is the 28.95, and we are going to add to that this ratio that we got of the distance between those two intervals and the interval that we're looking for, which is the 0.1982. And then we are going to subtract the lower number's upper limit from the higher number upper limit. So the higher number upper limit is the 29.15, and we are going to subtract from that the 28.95. And this is going to provide us with that unknown score associated with the percentile. So 29.15 minus 28.95 is equal to 0.2. So I'm just going to put this all in order for you to see here. So then if we multiply that, we should get 0.04. Let's carry out to 4 decimals. And then when we add the 28.95 to that, we should get a score of 28.99. And this is the score that is associated with the 80th percentile. So the 80th percentile score is estimated at 28.99. So here is the 80th percentile. So again, here, this is the upper limit of the lower number plus the ratio of these distances here that we're looking for. And then in the parentheses, we are taking the highest number upper limit and subtracting the lower number's upper limit from it to get the percentile.